Pure creatine monohydrate should have essentially no taste. This is not a quality marketing claim, it is a chemical property. Creatine monohydrate at high purity has a neutral, slightly powdery texture when tasted directly, with no detectable bitterness, sharpness, or aftertaste when dissolved in a reasonable volume of water. Bitter taste in unflavored creatine is a signal worth paying attention to. The primary sources of bitterness in creatine products are synthesis byproducts and manufacturing impurities, particularly dicyandiamide, which has a bitter, sharp quality, and dihydrotriazine compounds, which contribute similar off flavors. Both are byproducts of the creatine synthesis process that appear at higher concentrations when manufacturing quality control is inadequate. Taste is not a reliable quantitative indicator of contamination level d'ailleurs. The human threshold for perceiving bitterness varies between individuals, and some contaminants have lower taste detection thresholds than others. But a clearly bitter or sharp unflavored creatine product is providing sensory evidence consistent with elevated synthesis byproducts. It does not prove the product is unsafe, but it suggests that the manufacturing process may not be meeting high purity standards. Creapure and equivalent high-purity monohydrate products are characteristically tasteless when dissolved in plain water. If you have used a pure product as a reference point, the contrast when tasting a lower purity product is often noticeable. This is an informal quality check available to any consumer, limited in precision but potentially useful as a first-pass screen. Temperature affects taste perception of creatine in solution. Cold water reduces the perceived taste of most solutes, including bitterness from impurities. A product that tastes acceptable in cold water may reveal bitterness more clearly at room temperature. Testing at room temperature provides a more sensitive informal assessment than cold. Flavored creatine products use sweeteners and flavoring agents that readily mask bitterness. This makes taste as a quality indicator essentially useless for flavored products. The flavoring components dominate any signal from the creatine itself. The flavored product category, therefore, cannot be evaluated by taste in the same way that unflavored products can. The practical implication: for unflavored creatine, taste is a free, immediate quality signal available at point of use. A tasteless product is not proven pure, but a bitter product is worth investigating through label review, brand reputation, and third-party testing documentation. Consistently tasteless creatine from a well-documented source is the standard to anchor against. The bitterness-purity connection has been partially confirmed in independent testing of creatine products. Organizations that purchase and test retail supplements have found that products with higher dicyandiamide content tend to come from manufacturers with less rigorous purification processes. This is consistent with the hypothesis that bitterness serves as an informal indicator of manufacturing quality. High-quality creatine monohydrate also lacks the faintly metallic or ammonia-like aftertaste that can appear in lower-quality products. These off flavors are associated with different contaminant profiles. Metallic taste can indicate heavy metal trace contamination. Ammonia-like taste can indicate incomplete purification of the sarcosine starting material or byproducts of the cyanamide reaction. The practical taste test is most informative when conducted on a small amount of dry powder placed on the tongue rather than on dissolved product. Dissolved creatine is diluted, which reduces the sensitivity of the taste assessment. A pinch of dry creatine, 100 milligrams or so os, held on the tongue for a few seconds provides a more concentrated signal. Pure monohydrate produces essentially no taste beyond a slight powdery sensation. Any clear bitterness, sharpness, or metallic quality at this concentration is informative. Temperature sensitivity of the taste assessment should be accounted for. Testing at room temperature or slightly warm provides more sensitivity than testing with cold powder. Some individuals are supertasters, particularly sensitive to bitter compounds, and will detect trace bitterness in products that average sensitivity tasters find tasteless. If you are a known bitter supertaster, calibrate your assessment accordingly. None of this replaces analytical testing for contaminant levels. Taste provides a directional signal, not a quantitative measurement. A product that passes the taste test is not proven pure. A product that fails is not proven dangerous. But as a zero cost, immediate check available to every consumer at the point of use. It is more informative than ignoring sensory signals entirely.